Okay, we're going to take a look at some laws of logs. But before we do that, just a quick reminder that when we talk about the common log, that's where you just see log. Okay, what's implied there is that your base is 10. Okay, we rarely, if ever, write the 10 for the base. So anytime you just see the common log, understand that the base is 10. Very similar to the natural log, where the base is e. Okay, so with these laws of logs, they apply to any log, whether it's the common log, the natural log, or a log with any base. Okay, so I'm going to write these out just using the common log notation. Okay, so the first one here, if we have the log of x raised to the n, so you have a power. Okay, this says that the power can be dropped down in front and multiplied to the log of x. All right, so if we're talking about maybe log base 3 of 4 to the 5th, this would be the same as 5 times log base 3 of 4. Again, doesn't matter if we're talking about the common log or in this case a log of base 3. The bottom line is our power goes to the front of the log. Everything else stays the same. Okay? Okay, the next one here deals with the log of a product. So if we have the log of x times y, this could be expanded out. Notice how we go from seeing a single log to more than one log. Okay, so you have the log of x plus the log of y. So this plus goes with this multiplication symbol. Okay, go from seeing one log to two logs. So talking about things like the log of 3 plus the log of 5. Okay, it's very tempting to think that this is the log of 8. Feel free to put it into your calculator to look at the decimal to prove to yourself that it's not equivalent. Instead, this is the log of 3 times 5, or 15. Okay, so we can go from seeing one log to two logs, okay, where we are, again, this 15 is dealing with multiplication, 3 times 5, so we can expand that out from 2 logs here to 1 log. Okay? Okay, suppose we're looking at log base 4 of 2x cubed. Well, we can expand this out. Again, we're not talking about the common log here. We have a log with a base of 4. Well, we have our first, now understand there's really a product there, so the first part is 2. Alright, plus, then we have log base 4 of x to the third. Okay, notice how I expanded that out. And you could take this a step further. So you have log base 4 of 2 plus, we could now use our rule from the previous part where we can take that 3 and drop it down in front. So you would have 3 times the log base 4 of x. Okay? So what you'll see is that many times we can use multiple log properties within a problem. Okay, our last log property here deals with the log of a quotient. So if we have the log of x divided by y, this can be expanded out or rewritten or simplified as the log of x minus the log of y. So here notice how the subtraction, that goes hand in hand with our division. Just like before we said addition went with multiplication. So if we have something like the log of 4 over 3, this is the same as the log of 4 minus the log of 3. Okay? And again, it doesn't matter if we put a base in there of, how about 5? Okay, as long as the base is common throughout. Okay? And that's a key point that we need to make here. All of these log properties apply to examples where the base is common throughout. Okay, can't mix up the bases. Okay, in this example we are looking to express this expression as a single log. So right now we currently see there are 3 logs in here. They all have a base of 2. And we're looking to use our log properties to express this as a single log. Okay, so the way to do this is to just work left to right, if we look at the first two terms here, all right, we can see that we have a log base 2 that is common, and we have this 5. Now we see a plus sign. We know that's going to turn into a multiplication symbol. Now this 1/2 here in front, if we work backwards, we can throw that up here as the power of 36. So what we really have here is 36 raised to the 1/2 power. Okay? And then we have minus log base 2 of 10. All right? Now, if we simplify this a little bit more, 36 to the 1/2 power, well, that's really the square root of 36, which is 6. So we really have 5 times 6. So we really have log base 2 of 30 minus log base 2 of 10. And you don't necessarily have to show all of that work. If you're able to just look at it and recognize that it's going to be log base 2 of 30, just go right ahead and write that down. And then from there, once again, we have the same base of 2, so we can use our log property. Because we are dealing with subtraction, we're going to turn this into a quotient. Okay, so our final answer, when we express this as a single log, would be log base 2 of 3. Okay. Okay, last example here. We are told that we have A, B, and C representing these different log expressions, and we want to express what we're given down below here in terms of A, B, and C. So this means we're going to want to use a whole bunch of different log properties, as well as some exponent properties to rewrite all of this. So notice we first have the log of a quotient. So that suggests that we're going to be able to rewrite this using the difference of two logs. So that radical x, recall, is x to the 1/2 power. Then we're going to have minus. Now, there's a lot to subtract, so we're going to put a parenthesis here. We have the log of y cubed times z to the 4th. Okay? So we really have the log of this product. Well, from there, this 1/2, we know we can throw that in front. So we have 1/2 log of x minus, now I have a product here. So I could rewrite this as the log of y cubed plus the log of z to the 4th. Again, when we have a product, we turn it into addition with more than one log. And from there, we can clean this up. We can distribute our negative, and we could also take our powers and throw them in front. So minus 3 log y, and then we'd have a minus 4 log z. So again, this power is just going in front, and then I'm distributing this negative. And then notice from there, we can now substitute in for log of x, log of y, and log of z, what we see up above here. So we'd have 1/2 a minus 3b, and then minus 4c. So that would be our final answer expressed in terms of a, b, and c. So you're just using your basic log properties to rewrite it in a form where you could then substitute in and express it in the desired form.